So let's look at this function here, y equals u of x to the power p of x. So y is a function of two other functions, function u and function p, okay? And u and p are functions of x. So how do we take the derivative of this function? We use the same trick. We take the natural log on both sides. So natural log of y equals natural log of u to the power p. So the p jumps in front, properties of the log, and we have that. Okay? Natural log of y equals p of x times natural log of u of x. We take the derivative, we pick up this function, this equation here, and we take the derivative with respect to x on both sides. So the derivative of y of x, y is a function of x, so it's 1 over y, derivative of y with respect to x, which I will denote just as y prime. Here we have a product, right? So we have p of x, we repeat p of x, and then we take the derivative of this is 1 over u times the derivative of this, which is u prime of x. Okay, so it's this derivative of that bit here plus the natural log of u of x times the derivative of p, which is p prime. Okay, and then now we just multiply both sides of this equation here by y, which is u to the power p. So y prime is u to the power p times this. Here I multiply top and bottom by u. So I have p u prime plus the u p prime and the natural log of the u of x. Okay, I can rewrite like this or like that. Here I'm omitting the p, the x, but it's just rearrangements. Okay, so examples. If y is x to the power x, how do we, so the u here, u of x is just x, and the p of x is just x. So u is x, the u prime is 1, the p is the power is x, p prime is 1. So we apply the formula, we can apply this one here. Okay, we can apply this formula here, and we obtain our result, which is this. Another example, y equals 3 to the power x. Again, u of x is just a constant function 3. P of x is x. So u equals 3, the derivative is 0. P is x, the derivative is 1. We apply the formula and we end up with y prime is 3 to the power x, natural log of 3. Here instead of 3, if we had any positive number, it would be the same, right? So if we take the derivative of any alpha to the power x, that would be alpha to the power x, natural log of alpha for every positive alpha. Okay, same procedure as here. But this is more general, right? This allows us to have the formula for the derivative of any function of x raised to another function of x. So we could have much more complicated expressions, much more complicated functions. If we can write in this format here, we can use the formula to find the derivative. I hope you enjoyed. That's it. See you next time. Bye bye.